Continue our work with radicals and simplifying them. Just do a quick warm-up. So go ahead and you can work with the person next to you. Get a good jump on that one.
I'll work with my imagination.
Distance D in miles that you can see to the horizon with your eye. Level h feet above the water is modeled by this. So if you are 5 feet above the water, what variable does that represent? That's our h. Okay, so we're just plugging that in. We get d is equal to the square root of 3 times 5 all over 2. It's equal to 15 over 2, root 15 over 2. Okay, which is root 15 over root 2. Right? And then from there, you're multiplying by root 2 over root 2. We do that. Tell your neighbor why we do that. Okay, time's up. Volunteer, why do we multiply by root 2 over root 2? Sebastian? Can't have a root on the bottom. So that gets rid of the root. It becomes 2. Anytime you multiply a root by itself, you get the number inside. It comes out, and you get root 30. Anything go into 30, that's perfect. Any perfect square number. Nope. We're done. Okay? Now, if you rounded it, that would be about 6. Oh, there we go. Okay? Okay, very good. All right, I want you to take out yesterday's assignment, please. Go through any questions that we had on that. Start with the practice, the front side there. Before we do that, talk to your neighbors about those you struggle with. Compare work. Here we go. Need your attention back up here. Let's start with 1 through 6. What kind of questions do we have? Yeah.
So for number 3, if you can't really find the square root of 9.
Right, we can't find the square root of 98. So maybe at the top of all your papers, anytime you're dealing with square roots, just write your perfect square. So you have 1, 4. And we can kind of keep going on that. You write all your perfect squares down, and then if it's not a perfect one here, you say which of those perfect squares go into it. If none of them do, then you can't simplify it. In this case, it just so happens that 49 goes into it, and it goes into it twice. So you break it down to root 49, root 2. And that negative sign on the out there is just like having a negative 1, so we'll just kind of put that negative 1 and circle it. We're done with that. That'll be part of our end answer there. The reason we use root 49 is because it's perfect. It becomes 2, and then we bring down the root 2. Okay, so we have 7 root 2 and negative 1, so negative 1 and 7 is negative 7, and we have root 2. Any questions on what we did there? Any other questions on 1 through 6? That makes sense. Number 6. Okay. Similar to the previous one in the sense that there's that negative sign on the outside, so we circle it and we keep it. If it's a fraction, remember we break apart the top and the bottom. X squared is perfect. That is x. And the square root of 4, that's perfect. It is 2. So we have negative 1, x, and 2. So our answer is negative x over 2. Sebastian? 1x over. You don't want to put the 1 in front of it. Yeah. Probably. Yeah. Any other questions? Okay, let's move on. Actually, let me give you the rest of the answers there for 1 through 6. So number 1 should be 5 root 2. Number 2 is 2 root 1 or 2 root 17. Number 3 is negative 7 root 2. Number 4 is 3/5. 5 is negative root 3 over 8. And 6, negative x over 2. Questions there? Okay, go ahead and cruise down to the bottom, or the last 3 problems on that page. This was just asking you to write the factor that you can use to rationalize it. So what's wrong with this problem right now? Quinn? No. No, not on number 10. On these problems down here. Sarah, what's wrong with this? Square root on the bottom. You're not allowed to have a square root in the denominator. So to rationalize it, rationalizing it means just get the square root out of the denominator. Okay? We would have to multiply it by that square root over itself. Root 5 over root 5. That's what you're being asked to do there. You're not actually asked to find out what it is. It's just saying what should you multiply by. So we should multiply by that. Here we should multiply by? Okay? Here, this has a cubed root, so I didn't ask you to do that. And it's not as easy as just calling it root, or the cubed root of 9 to get rid of it. So we'll have to come back to a problem like that. Okay? All right, moving on to the other side. Go ahead and talk to your neighbors real quick about 14 through 22.
When you do it that way, do you just...
Okay, so here we go. Any questions on 14 through 19? Ignore the bottom row for a minute. 14 through 19. Sarah, what do you got? Number 19. Okay? First step. Everyone should be able to do the first step now. What's the first thing you have to do when you have a fraction in the radical?
You got to move it over.
What's that? Yeah, put everything in its own little square root symbol. Everything in there gets its own square root symbol. That's the first thing. From there, you can start breaking it apart. So are any of those things perfect? Z squared is actually z. So we're done with that part now. We can circle it. We don't have to do anything else with that. We took the square root of it. Why is it perfect? Because that's an even number. You just take half of it. You divide by that. Okay? All right, so square root of it. That's perfect. Very good. You divide that by 2, you got it. Okay, z to the first. Here, perfect? No. Root 7, perfect? No. Okay. And so what we need to do is figure out, is there anything that will go into 7 that's perfect? No. Anything that will go into 2 that's perfect? Is there any way to reduce these? They're both in radicals, so does 2 go into 7? Can you reduce that fraction? No. So the only other problem then, we're done with this. We can't do anything with that root 2. However, the 7, what's wrong with this?
Can't be a radical at the bottom.
Yeah, you can't have a radical in the bottom, so you have to multiply by root 7 over root 7. Okay? On the bottom, what's that give us? Just take the number out. It's just 7. Okay? And here we have root 2 and root 7 is root. What is root 2 and root 7? Come on, man. Root 14. And this is z. Can I simplify root 14 and 7? No, one's inside, one's outside, right? No, we got the 2. 2 times 7. Isn't what 2? Any questions there? Sure you got it? Yeah, except for you can't break this down because that's inside the radical. That one is. Okay. Any other questions through 19? Yeah.
Not through 19.
Okay. Hold on. We'll come back to those. Any up through 19? Okay. Answers for through 19. Number 14 is root 13. Number 15 is 9 root 5 over 5. 16 is root 6 over 10. 17, 4 root W over W. 18, root 5t over 5t. And then 19, z root 14 over 7. Okay, let's move on. 21, or 20 through 22. Which one did you want?
22.
22. Okay, note the difference between this, where you had a root 7 on the bottom, and this one, where you have a root and something else you're adding and subtracting. This is in parentheses. So to get rid of a root when you have another term down there, you have to multiply by its conjugate. The conjugate of this is the exact same values. But if that's minus, this is going to be plus. And you can't just randomly multiply by something. You have to do the same thing on both sides of the fraction. Bar there, therefore, you're actually multiplying by that whole thing right there is 1. Anything divided by itself is 1. So you're not changing its value, you're just changing the form. Alright, so when I multiply this out, remember this is the pattern a minus b quantity squared. Or excuse me, a minus b times a plus b. Which is the same thing as a squared plus b squared. It's the difference of two perfect squares. So if you have this and this, like this would be my a term, this would be my b term, then you're always going to just take whatever a is and square it, take whatever b is and square it. So in this case, negative 2 squared, that is not plus, that is minus. Excuse me. Okay, we're going to go ahead and this will be negative 2 squared, or negative root 2 squared, which is root 2 squared, which is 2. Okay, and then 25 minus 2 is 23. Okay, so the bottom becomes 23. That, make sure you make that change there. That shouldn't have been a plus sign. That's difference of two perfect squares. Okay, and on the top, we get 15 and, not 15, excuse me, 5 root 3 plus root 6. Can we put root 3 and root 6 together? Tell your neighbor yes or no, why or why not. What do you guys think? You think you can? What do you think? No? How come? How come? Hey, are right here? How many? You have 5 of what? You have 5 little root 3s. You're counting up root 3s right here. Here you're counting root 6s. How many root 6s do you have? You have 1. You have 5 root 3s and 1 root 6. You are not counting the same thing, therefore you cannot combine them. Okay? When you add, you have to have like terms or like roots. Okay? No, 5 root 3 and 5 root 6 you couldn't either because you're still counting different things. If it was like 5 root 3 and 3 root 3, you could. Yeah. You have to have the same root, same number inside the radical. Okay, so our final answer would just be 5 root 3 plus root 6 all over 23. Any other questions there? Okay, number 21, or number 20 should have been root 6 plus 1, all divided by 5. 21 would be 12 minus 3 root 2, all over 14. And 23, that is our solution. You should have just plugged in your values there. Okay, you plug in your 422 for your V2 and your initial investment. V1 was 400, You do the math, you get a rate of 0.027, which is 2.7%.